my goodness. Welcome to the O-Scope Wizard. I am Gabe, the O-Scope Wizard. I am struggling, trying to use some new software here. Hopefully, my microphone, let's see, we're going to adjust it a little bit. It'll be a good time to talk about Band Shirt Tuesday. I'm wearing Jukebox the Ghost today. It was a band that was actually recommended by one of my buddies, Javin. Thank you so much. They are pretty cool. I love them. And you have joined me in the techno lair today so that we can nerd out for, I don't know, about 20, 30 minutes, something like that. And we have a lot of ground to cover because we are working on building a totally wireless, almost, subwoofer to add to our outdoor sound system. Very exciting news. I was able to actually build the first prototype. So this is my first prototype of the subwoofer. It's a 5-gallon bucket. The only 5-gallon bucket that was in the garage. And I put the subwoofer down in it. My plan is to actually take this subwoofer, put a lid on it, put a pipe out of it, bury it in the ground. And I have some test leads coming out of it. This is Mark 1 of my 5-gallon bucket subwoofer system. We'll see how it works. I think that I have some chat windows to open up here. Okay. Thanks for joining. I see you in the chat, Mr. Bald Engineer. Thank you very much for joining. It is New Software Tuesday as well, as I struggle with trying to get a piece of software called Restream to work and make everything connect between all kinds of different services. I don't know how to do it, and I'm starting to feel a little bit like my parents struggling with their phones, and I just am like, dude, it's so easy. You just hit the blah, 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 and you hit 9 buttons, and then it works. And now I understand their plight because I cannot get this stuff to work. I got 900 windows open. Oh my goodness. And chat says I need a flashing 12 to really bring home the point. The flashing 12 of the VCR that was the bane of VCRs my entire life growing up. Nobody ever set the clock on the VCR. They didn't. I mean, how are you going to? So I think what I should do is let's see if I can resize some windows, so at the very least I can try to see some chat going on at the same time. Oh my goodness, I was trying to do this long before the show started, but then I realized I kind of ran out of time. So let's get into the main scene. So this is our system that we're working on today. I want to do 2 things, and you know what I realized I haven't been doing, which is typing in like the title of the episode. So I want to make a low pass filter, and I think I probably need to turn this on so you can see it. Low pass filter for our wireless subwoofer. If I can spell woofer, you know what? Our wireless subwoofer in a bucket. Does that work? I think I might need to make this a little lower so that it'll fit. There we go. That's what we want. We want a low pass filter for our wireless subwoofer in a bucket. And yeah, real-time title cards. This is a totally pro production here. It's definitely not just an old dude in a basement. I want to use my new breadboard, which I'm pretty excited about because I have a lot more space, to run some low-pass filters through my little Class D amplifier that I have over here. I have a, what was it, a TP... Turn the camera to follow me. TP 311. It was a TP 3118. So it's a Texas Instrument Class D amplifier on this little board. And it does do a great job amplifying the signal, which is awesome. Step one, taken care of. Step two, can I make this low pass filter? So after the show ended last week on, was it Baby Friday? I think it was Baby Friday. Last week on Baby Friday, after the show ended, I was hooking up some things to my output to just had a quick low pass filter. A lot of folks, when they're building a low pass filter, they'll just stick a capacitor on the speaker leads to just knock the frequencies down, and that does work. So I was doing that on the output of my amplifier. And then I thought, you know what? The other part, let's get this lower so we can see. The other part that I need for this low pass filter is an R, right? I've got a C, so this is my C. If I make a passive RC low pass filter, the most classical low pass filter, I should be able to control the frequencies and cutoff frequencies. And then I took, oh man, I took my potentiometer and hooked it up over here on the powered side of my amplifier. And it worked for a second, and then folks, bad things happened. Bad things happened. I let the smoke out of this potentiometer. It has been with me for a really long time. This potentiometer has been with me for, let's see, what year is it? I graduated college in 2003, and it is 2021. That is 18 years, I believe, if my math serves me properly. I blew up my 18-year-old potentiometer. I lit the smoke right on out of it because I was doing something pretty foolish here. I was hooking up my filtering on the powered side of my amplifier. So now I've got a lot more current flying around. I mean, the whole point of this amplifier is to take a little signal and make it a big, strong signal. And if I'm going to put filters on the big, strong side, I need big, strong components, and this little itty-bitty potentiometer just didn't fit the bill. Also, you'll notice I have just a whole slew of little resistors over here. Those can't go on the high side of my amplifier either, so I need to... I see what chat's doing there. I should have probably thought about that. I did smoke my pot. I smoked my pot. I did it. I just blew it right up. I realized, Gabe, come on, man. There's a thing called a preamplifier. So before the amplifier, preamplifier, that's where I should do my signal conditioning. That's where I should put my filtering. So getting smarter over here. We are going to put our low pass filters on this side of the amplifier, the input side of the amplifier, and then we're going to see what happens on the output side of the amplifier. The output side of the amplifier goes into a speaker. Speakers are differential signals, so they don't really have a ground and a positive. They just have two leads to the coil. With that in mind, I actually got a differential probe to look at that side so that I won't be constantly pulling one side to ground. So I got this little ZD20 that we're going to use to measure the output of my amplifier. And the input is a single-ended signal, so it's just signal and ground. Let's see if I can catch up with chat. People are saying that they love people manipulating OBS in real time. Oh yeah. Nobody ever has their stream set up properly when they hit go. They hit go and they're like, all right, I need 18 more minutes to get this stream set up right. But I'm not gonna mess with it anymore. I definitely hit the record button this time so I can, edit all this on the back end. You guys don't need to worry about that. Next steps. Let's talk about what my flow is going to be. What I'm planning to do today is use Bode Plots to characterize some filters that we're going to build. So we're going to use resistors, capacitors, and one of the suggestions that happened on the last show was that I should make an active filter. Now, I'm still here. Inside of my bag, or inside of my old toolbox from college, if I can move my camera so we can see my old toolbox from college, right here, inside of this toolbox, I have tons of different components including old 7400 logic and 555 timers. And when I was looking through this toolbox with all kinds of old components, because I never threw any of them away, I found a couple of operational amplifiers. So I have two operational amplifiers, aka op amps, that I can use, I think, to build some active low pass filters. So I want to do two things: build some passive low pass filters, see what they sound like, and then switch over to an active low pass filter and see if that sounds better or worse, or can I even tell the difference in sound? I'm not sure. I'm not sure. I don't know. I mean, it should sound different at the very least because it'll have a different cutoff frequency, and potentially it will be a different order filter. So instead of a first order filter, maybe it'll be a second order filter. So to have a bit of a steeper cutoff. So I'm going to try to do that. I'm going to try to do that live. For the Bode plot, I'm going to use my oscilloscope, and I'm going to generate a signal out of the back of the oscilloscope. And how am I going to do that? I actually have some explanation pictures. I have some RCA to 1/8 inch cable, so you know, the little headphone adapter that looks like that. I have that adapter on one end, and then I have some RCA plugs on the other end. And I bought some RCA to BNC adapters that I plugged into that cable. And then I plug, let's see if we can see this. I plug these cables into the back of my oscilloscope. And on the back of my oscilloscope, I have a handy dandy little signal generator. So I'm going to use this signal generator. Uh-oh, don't save the changes. I'm going to use this signal generator to generate, you know, some sine waves. And we're going to test this fixture. Happy Band Shirt Tuesday to you too. Chat's actually, man, I do love the chat aspect of this. It makes me feel like I'm not alone. Oh, the 900 megahertz signal generator right above the ARB. Oh no, what are we talking about here? What am I looking at? Oh, we're talking about the wireless dongle. We're talking about the wireless dongle. Man, that's a 2.4 gigahertz signal generator right above the ARB. That's going to be totally cool. You got a little Wi-Fi dongle plugged into the back of there. I actually forgot I had that Wi-Fi dongle plugged into the back. I think that one is a Wi-Fi dongle. I have a 900 megahertz keyboard dongle that I use, and I even bought. This is crazy, but I bought some feather wings, 900 megahertz feather wing add-on boards for Raspberry Pi as potentially a wireless sound transmission device. I don't think they'll work, but oh man, people are not mature enough to hear the word dongle. Dongle is a weird word. Dongle is, you know, it sounds naughty. It sounds naughty. That's the end all be all of the word dongle. I'm going to plug in some things, and we're going to start measuring some low pass filters. I figured, though, to begin with, let's figure out. We need to pick some cutoff frequencies. So this is the speaker that I harvested my subwoofer that is in the bucket from. So I had an old Dayton Audio subwoofer, and I thought that I could look through this subwoofer's specification and kind of figure out what the cutoff frequency was originally. I think if I go over here to the manual, which is as close to a data sheet as I'm going to get with this guy, kind of a bummer. I can see that they originally had a low pass filter built into this subwoofer that was variable between 40 hertz and 140 hertz at 12 dB per octave. 12 dB per octave, is that a first order filter? I think it might have been. Um, but the actual subwoofer's frequency range is 30 hertz to 140 hertz. So that is what the subwoofer should actually be able to output. So this guy, where the subwoofer came from, it was totally unlabeled. So there's no way for me to look up the actual model of the subwoofer speaker. I'm going to have to go off of this data sheet, which is not even the same exact subwoofer that I have, but 30 hertz to 140 hertz sounds about right for this 10-inch sub that I have in my 5-gallon bucket. And I think it's a 10-inch sub. I should probably measure that. Next, let's figure out, so these are the speakers that I have outside right now. So these are OSB, what is it, outside patio or something, outdoor speaker, some kind of random outdoor speaker that I bought off of Amazon last year. And there, if I go to the website, it says that their frequency response is allegedly 37 hertz to 22 kilohertz. I mean, there's no way that these things go all the way down to 37 hertz. So, I mean, technically, they probably do vibrate at 37 hertz, but not with any power at all. So I want to supplement the low frequencies of these guys. And it seems like if I was to follow the subwoofer's frequency, I should put a cutoff frequency around 140 hertz just to follow the frequency response of my subwoofer. We'll see how close we can get with the little components that I have, because I have, well, you know, I have kind of a mess of little capacitors and resistors, and I did buy some extra capacitors here. If we point this back here, so I have a couple of extra capacitors that we can use, but I don't have a limitless supply. So this is a real engineering challenge. Given limited resources, what's the best? What is the least amount of compromises I can do when I build my system? Now, back to the browser to do some calculating. So here is the very first low-pass filter we're going to try to hit. So just an R and a C. And I found this calculator online, and the reason I chose this particular page, which is learning about electronics, which I probably link in the description at the end. The reason I chose this is because it has a calculator for both a passive RC filter network, and down at the bottom of the page, it has some calculators for an active op-amp-based low-pass filter network. And I want to try to build both and kind of compare them to see what they sound like. We'll see if they sound good or bad, or I don't know. And also up front, I should tell you, the only expertise I have in this is I was born with ears and I can hear. So we'll see how good this sounds to my ears, which means, yes, we are going to make a lot of measurements, which is one of the things I love about audiophiles videos, is they'll make a ton of measurements, and then ultimately the guy will come on and he'll say, hey, you know, this one sounded better than the other one to my ear. Okay, well, that's not objective at all. That is not measurement based. That's just a subjective opinion. And just fair warning, that's where we're going to end. We're going to start with a bunch of objective measurements and end with a subjective opinion. Oh, it sounds warmer. Yes, it sounds so, oh, they love it. I think when I think about sounds warmer, I think tube amps, and I think the part that sounds warmer is the fact that the tubes glow. And I will admit, I did think about building a tube amplifier just to make it look cool. Before I started using this RC network calculator, I wanted to confirm that it was actually working. And I remember I kept talking about this website that I like, that was sort of like a program called MathCAD. I loved MathCAD in school for my reports. And blockpad.net is the website that I was thinking about. Chat says, nitrogen injected cables for the win. Nitrogen injected cables. nitrogen injected anything is something that really interests me because I have allegedly got nitrogen filled tires outside on my vehicle. And I got to thinking, what is the just real quickly, what is the percentage of nitrogen in air? 78%. I was pretty high. My head is right in the way. Come on. Oh my gosh. Oh, let me get my head out of the way so we can see this. Google says our atmosphere is made up of 78% nitrogen. That means technically everything is nitrogen filled, guys, unless you're pumping out the nitrogen. Anyway, small aside, nitrogen filled. Is that considered this? It might. It's not really a dad joke. That's more mansplaining, I think, technically. All right, away from mansplaining, we'll start using this piece of software that I like to try to do my calculations. So let's just make a really simple RC network. So we will say we're going to use a 1000 ohm resistor. There we go. And let's do a 1 microfarad capacitor. So 1 times 10 to the negative, times 10 to the negative 6 farad capacitor. There we go. 1 microfarad capacitor, 1000 ohm resistor. Our frequency for cutoff will be 1 over 2 times pi times r times c. And that should equal 159 1 over ohm farads. I'm not sure BlockPad's doing my unit conversions perfectly, but there we go. Oh man, BlockPad. I wish that I wish you did do the unit conversion. Sometimes it does the unit conversions pretty well, but maybe I'm asking too much of it to do an electrical engineering unit. What did I just hit? I just. Oh my gosh. Oh, sweet mercy. Really? I hit a button. Oh my gosh. I'm like my father. Well, 159. It was 159. 159. I just want to type it in really quickly. I do like BlockPad for those of you that are wondering how awesome it is. So 1000 ohm C 1 times 10 to the minus 6 farad, and FC equals 1 divided by 2 times pi times R times C. There we go. There we go. 159. I hit this little side button on my mouse and somehow, I'm not even really sure what the side buttons on my mouse are for. It's a gaming mouse and it's supposed to make me faster somehow, like twitch, twitch, twitch. I don't know that it does. But let's do the same thing over here and see what our answer is. So 1000 ohms, 1 microfarad, calculate. Okay, they got 159.23 and we got 159.15. I suspect one of us is using a different number for pi, but that's pretty close. So I'm pretty comfortable with this setup. And in fact, 159 hertz. It's kind of just typing these in randomly. But if I got a kilo ohm resistor and a 1 microfarad capacitor here, I should be able to build a 159 pi equals 3. Oh my goodness. Pi equals 3. And Chad asked, is there a website that does gaming? Come on, man. This is engineering gaming. The game of life. There are 1 or 2 streams that actually do gaming. I've heard. Allegedly. So 1 kiloohm. I don't even think I grabbed a bunch of resistors out of my bag, but I don't think I grabbed a kiloohm. So a kiloohm, I have this handy dandy resistor card to help me remember what what all the numbers mean. So I need brown, black, brown, black, red. Brown, black, red is what I need for a kiloohm. Did I grab a brown, black, red? I don't think I did. I got brown, black, brown, brown, black, brown, 100 ohms. Because I do have a 1 microfarad capacitor over here. 1 microfarad capacitor. I get to open it up. I'm pretty excited. I got 2 of them. Let's find. I even got resistors out before the show, thinking that nobody wants to watch me haul through resistors. Brown, black, red. Can we? Oh, goodness. So you can follow along with me. I got a whole stack of, oh my goodness, resistors that are going to fly everywhere. Brown, black, red. There we go. Brown, black, red. Got it. Brown, black, red. Is it the colors in this webcam leave much to be desired? It almost wants to focus too. I think that's brown, black, red. We're going to get one Bode plot done, and we'll see what it sounds like. Next, because I just want to make sure I have my multimeter over here so we can actually measure this to make sure it is a kiloohm. Plug my multimeter in. Chat says, one of my chat buddies, he also does all kinds of engineering experiments, and he's better at it than I am. But he does dig around for resistors and stuff sometimes. It's funny. He said I was attacking. All right, where are we at here? Whoa, my multimeter is all over the place. It should not be quite so exciting, multimeter. Oh, you know what? I got them plugged in backwards. Does that matter? Actually, that doesn't matter. Gabe, what are you talking about? Plugged in backwards. Why is my multimeter jumping around like a crazy thing? Okay, I'm not doing a diode test. There. Oh, you know what? I was on the diode portion of my. Do I have, you guys seeing how much jumping around there is? Maybe I have a lot of corrosion or something. Something ain't right. Something ain't right with my multimeter here. There we go. I think my cables might have been. There we go. 1 kiloohm. Disturbingly bouncy. I think my. Could it be that my $0 cables that I somehow managed to just acquire are not the most awesome leads in the world? That could be. I'm going to take this 1 kiloohm resistor, set up my filter, and we're going to make a measurement. We're going to get a measurement made. So V input. Okay. Kiloohm resistor to the input side of my board here. Right there. Kiloohm resistor, and then I want a microfarad, 1 microfarad capacitor. Picked up for $2 at the store. If you're wondering, is that a good price? That is a terrible price. If you were to buy these in bulk, they would be pennies. But we have a nerd store right around the corner from my house called Micro Center, and it's where nerds can go to have a safe space. It's kind of like Fry's used to be. But nerds can go there, have a safe space, And it's nice. It's nice, you know. What do I want here? I want to go to the negative side of my input. $0 cables, yes. I'm sure I'm not the only one who uses $0 cables. They're just like, how much do we have left in the budget for cables? So we have $0 left in the budget for cables. That is how much I had left in the budget for cables. Okay, am I doing this right? So VN, if I was to follow my little diagram, I plug it in, right? VN will go here. This will be the input of my amplifier with the capacitor across the leads. Okay. If I can figure that out. How does one... Let me go up here where I have a little bit more space. I have all these wires and things. Why am I making it so little? I used to do this in school too when I was building circuits. You'd make this circuit just so tiny. So it took up just this minimal amount of space on this huge breadboard. And I don't know why I do that. Don't know why I do that. You know? Who knows? Who knows? But I have more cables. There's no reason why I can't use more cables. Chat says when you have no money for cables, you just go to the parts bin and make your own. Chat, you're not wrong. You're not wrong. I have speaker wire that I make extra cables out of all the time. All the time. Okay, so VN. We'll go into my input of my amplifier. There we go. Bada bing. Bada boom. And V out is right over here on this side. And I'm going to measure it today with a load. I actually have my resistor that I oftentimes make very hot that I'm going to use to actually load my amplifier while I'm making these measurements. Because I was curious, you know, loaded versus unloaded. I don't know. There's going to be a difference. There's going to be a difference between the loaded response and the unloaded response of an amplifier. And I am going to be using this amplifier loaded with a speaker. So let us load it with this 8 ohm power resistor, which is an 8 ohm, 50 watt power resistor, so we can see the response. And I think we're going to be able to, I think we are going to be able to make a Bode plot happen. All right. Next, let's hook my oscilloscope probes up. The oscilloscope will be probing the input of my amplifier on channel 1 with this little passive probe. Oh my goodness, with this little passive probe. And the output of my amplifier with this differential probe, since my speaker is differential. There we go. So we got inputs and outputs, and my filter's right there. The next thing that I need to do, probably turn on my amplifier and see if it works. The subwoofer is 4 ohms. Maybe. Will the subwoofer be 4 ohms? That's a good question, actually. I think that this subwoofer that I'm using, let's just real quick go check it out. Does it say whether it's 4 ohms or 8 ohms? A lot of times they are 4 ohms. I'm not sure if this subwoofer is 4 ohms or 8 ohms. I mean, as I was saying, there's no markings on the thing. Is there any indication of the impedance of this guy? I don't see any specifications, overview. It says it'll do 100 watts. Oh, there was a frequency response right there, huh? I don't see 4 ohms or 8 ohms. You know what? We can make it. We can make a 4 ohm power resistor, as luck would have it. Let's do that. Let's do that just because a lot of times, Chad is right. A lot of times the subwoofer is 4 ohms. Whoop, we need something here. There we go. I have a second power resistor over here. If we put these two power resistors together in parallel, they will be 4 ohms. If I have two 8 ohm resistors in parallel, that makes them 4 ohm resistors. So I shall do that. Use this other wire over here so you can follow along. Boop. There we go. That's one resistor in parallel, or one side of the resistor in parallel, and the other side of the resistor in parallel. Now I have two resistors in parallel. Both of them are 8 ohms. That makes my 4 ohm power resistor. It's cool. Cool. That is Ohm's law at work. We shall hope that works. We shall hope that everything is plugged in right. I think it is. I think it is. So let me plug in the actual power supply. Nothing's smoked. Always a good sign. Always a good sign. Always a good sign. Now I actually have some software that should make it a little bit easier for us to do these Bode plots. Let me see if I can get this software running here. I want to share my display over here. Here's my scope. I have channel 1 and channel 2 for the input and output. And I also have this really clever Bode Plot software. We think that this filter that we just made really quickly is 150 ohms. So I'm going to make a Bode Plot. So if you guys don't know what a Bode Plot is, I have some other videos on my channel, on my YouTube channel, when I was designing my other amplifier, and I did a bunch of Bode Plots. And we'll do more Bode Plots, but essentially it takes a frequency and sweeps it from a start and a stop frequency and compares V out to V in and just plots it on a screen, on a grid. So we are going to start our frequency from 10 hertz and we'll go up to 20 kilohertz, which is, you know, my hearing range. Maybe 10 hertz might be a little low, 20 kilohertz might be a little high, but that's what we're going to call it, to do a very small input signal. So I'm doing 50 millivolts input to mimic just the output of, you know, like an iPhone, headphone out of an iPhone, pretty small voltage. I think that I have all of this set up. So let's run the test. The test that's up here right now was just the output. Well, look at my head. My head is literally right in the way. Get out of the way, head. There we go. This plot is just V in of V out of the amplifier, and you can see that it has a pretty flat amplitude response all the way from, you know, 15 hertz up to 20 kilohertz. So it stays between 31 and about 33 dB of gain. So it has a lot of gain, but a flat gain, which is good. Let's try it with our low pass filter on the input. So I think I have this plugged in similar to this this connection diagram. So I have the generator going to the input of my filter. I am probing the output of my filter, and then I'm also probing the output of my amplifier. Okay, in the back we can see this, my scope. This is what the scope is doing. The yellow channel is V in, the green channel is V out. I should see I think. Wait a second. Am I doing this incorrectly? I think I have this hooked up wrong. I think I have this hooked up wrong. I do. I have it hooked up wrong, guys. On my scope. On my scope. I have the scope hooked up incorrectly because I'm I'm essentially just probing the same thing twice. If I go back to my webcam here, I need to move my scope probe over a little bit. And I need to probe the thing that's coming in right over here. So I need to actually probe where the voltage input comes in, not after my filter. I need to probe before my filter. Because I already have a probe after my filter, and I don't need two probes after my filter. Goodness gracious alive. I can't even plug things in the right order. What kind of a wizard are you? The Kmart wizard. Kmart wizard of oscilloscopes is what I am. That's the best I have. Let's try that again. Let's try that again. I think that I should have it plugged in per the diagram for real this time. For reals, for real. So, signal looks good. Everything's looking good. My phase is kind of swinging down a little bit. I want my phase to be flat-ish. Okay, look, we're starting to get a roll-off. We're starting to get a roll-off. That, folks, is a low-pass filter. That's looking like a low-pass filter to me. Very exciting. Very exciting. We built a low-pass filter with passive components. And the phase goes crazy and wonky at the end. Hey, it works! It works! Our low-pass filter is working. The cutoff frequency of about 150 hertz. What is this? Let's see. This is 100, 200. So right in here, cutoff frequency. Does this thing have, I don't know if my graph has, it does not have markers, but it does have a table. So if I go out here and I look, let's see, we are up at 30, 30, 30, 30, 30, 30, 30. So my cutoff frequency is technically, when I go down to 27, because that'll be 3 dB down. So 27 is right here, 196, or I guess 30.6, 30.6, we'll call 30.6 up. So now we're at 27.6, 171. Yeah, 171 hertz is my cutoff frequency, which matches the diagram. That feels pretty good. Guys, we built a low-pass filter, a passive low-pass filter for our subwoofer. We are going to have to do some more experiments. That took a really long time. Oh my goodness. The phase looks fine. One of the things that you want from your filter network is to have as flat a phase as possible, but I mean, as flat as possible is, the goal. You don't want it to go crazy because that'll do weird things to your sound. But it's a nice smooth phase plot, so I feel pretty good about that. Next, we are going to actually run some music through it and listen to it. That'll be on the next episode, though, so not on this episode. We already did all we could on this episode. We built a passive first order, one order. We built a passive one order RC resistor capacitor low pass filter for our subwoofer. We did a Bode plot of it, and we confirmed that our calculations of 150 hertz, or actually it was 159 hertz cutoff frequency, and the measurement was actually 170 hertz. So that's really close, given that we're using these just cheap 18-year-old components. Well, the resistor's 18 years old. The capacitor's probably newer than that. Chat says, yay, tolerances. That is so true. I mean, I'm working with a resistor that has, I think, 5% tolerance. So the capacitor has who knows how much tolerance. I'm not even sure. Only there was a person in the world who could tell me how to tell what the capacitor tolerance was. So these capacitors will have a tolerance. I'm just not sure off the top of my head what to tell you. Oh, 20%. 20%. Oh, there is an expert in the chat. The expert says capacitors have, these electrolytics have a 20% tolerance. 20% is wildly large. I mean, that's a huge tolerance. But thank you very much, Bald Engineer, for letting me know a little tidbit. On the next episode, we will listen to some audio through this low-pass filter to see what it sounds like, or to hear what it sounds like. I guess we won't see what it sounds like on account of it being with our ears. And then we will attempt to build an active low-pass filter and determine if that's better or worse. Does it sound better? Subjectively, do I like it better? Do I think it's cooler? Maybe. We got two op amps to try. So that'll be exciting. Until then, I don't know all the nerds in the world, and I would love to meet them. So please share this with the nerd in your life, and I will see you guys next time. I'll hang out in the chat. Take it easy, guys. Bye.